at any time. Okay, next. All right. A cork is a type of wood. They usually use it to bottle things. So a cork can float on water. Why? Now, if you don't like corks, then your rubber ducky. Why does your rubber ducky float on water? Okay, well, digital. I love your enthusiasm, though, Mouse. Oh. Oh, that's 28 responses. Everybody's confident on this one. Let's see. 100%. Yes, it has to be less dense than water. It has to be less dense than water. If somebody put equal in density, I would have to give you that as correct. I would have to. Because remember, tie goes to buoyancy. So if you have something with the same density as water, what's the density of water again? 1. So if you have an object that is 1 as its density, it kind of stops wherever you put it. So if you put it on the surface of water, it will float on the surface of water. If you take it below water, it'll just hover there, right? It'll stay wherever you put it if it has the same density. Question? Yeah, but water's perfect that way, right? Because remember, 1 milliliter of water equals 1 gram of water, so 1 divided by 1, 1. A box placed in water. Now, I don't know what kind of box. It could be your toy box. It can be your cereal box, whatever. But you put the box in water and it sinks. What could you do to that box to make it float? And let's say that, what can you do to that box to make it float? There's 2 things you can do, but there's only one result of what you do. So that's the answer I'm looking for. Okay, we have 22. Now remember, if you don't know it, take a guess, right? This is anonymous. So I don't know. I can find out who you are, but I'm not going to. It's anonymous. So just take a stab at it, right? Or talk amongst your group. I have 24. Let's go ahead and take a look. Density. Yes. You can change its density. You would want to lower its density. What's 2 ways that we can lower the density of that box? What's 2 ways? Make the mass lighter, smaller. Make them last. So take things out of the box. Maybe it'll float. What else? Yes. And that's changing its what? Starts with a V. Volume. Hey, remember this. If you want something to float, change its volume and make it a boat, right? Anything will float. When I was going to Fresno State, the engineering department was trying to make a floating concrete canoe, a canoe made of concrete. And they did it by increasing the volume enough so that it ended up able to float. Now, I wouldn't trust it and get into it, but I actually saw that it did float. You can make anything float as long as you shape it like a boat. So you have 3 identical 1-liter bottles. Now, if that's confusing to you, change it to 2-liter because you like soda, and that's a 2-liter bottle. So let's say 2-liter bottle instead of 1. So now you know what we're looking at. We're looking at soda bottles. In one of those soda bottles, you put water. In another one, you put air. And in the last one, you put soil, like dirt. So now you know what's different about it. What's the same? What is the same? Digital. I know. What is the same about those 1-liter bottles? What is the same about all of those 1-liter bottles? All right, we have 23. Let's take a look. Volume, yes. 1 liter is a volume. Remember, we use the metric system in science. What do we use in the United States? What system do we use? The customary. But we don't use those words in here because those are cuss words, right? Like if I said gallon, I know what gallon is. We can't use it because that's a cuss word. It's a customary unit word. We cannot use that word. So we use liter. Bonus question on this question. How many milliliters are in 1 liter? How many milliliters are in 1 liter? 1,000. Remember, the word milli means 1,000. So like when the year 2000 came, you probably weren't born yet. It was the millennium. Milli, meaning 1,000. Okay? It was a pretty good party. Too bad you weren't around. All right. Next. Forces can only be added together if what? You can only add forces together if they are what? 4 results, 5 results. Come on. You can only add forces together if they are what? Did they die? We're just going to use his? Okay. 16, 17, 18, 19 responses. We'll do this one on 20. There we go, 20. Let's see if they're acting on the same object. Yes, you can't say, hey, I want to add forces of that dog as well. Doesn't work. In baseball, you can't be playing and the other team hits a home run and you're like, I'm going to take your points. You can't add the other team's points to yours. It's not yours. If you play volleyball, you can't get spiked on and then go, yeah. And they go, why you got spiked on? Why are you happy? I'm going to take that point. Doesn't work that way. You can only add the forces up if it's acting on the same object. Next. So what is the force called if you have an object that is rubbing against another object directly? We did a lab on this. Remember, we had a brick and we pulled it across cement, we pulled it across a desk, and we pulled it across carpet. What was happening between those two surfaces? What was happening between those two surfaces? All right, there's 20. Let's see. Friction. Ooh, 100%. Good. Remember, friction is the opposition to motion. So bonus question. When the object is rubbing against directly another object, what kind of friction do we call that? Sliding friction. If we put wheels on the object, what do we call that friction? Rolling friction. Good. If you're trying to move the object and it's stuck and it's not moving, what friction is holding it there? Static friction. Good. Remember, friction is the opposition to force. It is what brings things to a stop on our planet. And we like to say that in comic books, the Joker is always trying to force evil on Gotham City. But who's always there to stop him? Batman. So the Joker is like a force trying to cause motion, and Batman is like friction, always there to stop him. And who's Batman's weak little friend? Robin, and that's gravity. So the weak force of gravity works with the strong force of friction to ultimately bring all objects on Earth to a stop. Good. Next. Ooh, this one always tricks people. You know it, though. The force of gravity acting on a person or object on the surface of a planet affects this. Think about it. It has to be on a surface of a planet because if you're in outer space, this is non-existent. Okay? If you're in outer space, this is non-existent. So it has to be on the surface of a planet. All right, let's see. Ooh, we're all over the place, but weight wins out, and that's true. Now, remember, your mass is your mass is your mass. Your mass on Earth is the same as your mass on the moon, is the same as your mass on Jupiter, is the same as your mass on the space station. But your weight changes depending on where you are. You are 1/3 less weight on the moon because there's 1/3 less gravity. You have 0 gravity in outer space because there is 0. You have 0 weight because there's 0 gravity. So weight is what changes based on the surface of a planet. Please remember that. Hint, hint. Air resistance. I wouldn't trust that answer. Air resistance is a type of what? Is a type of what? Okay, there's 20. Let's see if we got it. Friction. Good. Yeah. Now, that may not seem like that big of a deal to us because no matter how fast we run, the air resistance is just going to feel like a little bit of force trying to stop us, right? But when we accelerate that to something even faster, then friction shows us exactly what happens when we rub our hands together. When you rub your hands together, what is produced? Heat. Now imagine a spaceship coming into our surface of our atmosphere. It hits the air. Because it's moving so fast, what does it create? Heat. So you need to have a very good working heat shield in order to protect whoever's in that spaceship. Okay. One of the worst shuttle disasters was because the heat shield failed. One of the heat tiles on the bottom didn't work. And as the shuttle was coming into re-entry, it blew up. And 7 astronauts lost their lives because of air resistance. Does anybody watch that show, The Flash, that just came out this year? The Flash? It's actually pretty good. I thought it was going to be kind of hokey, but it's actually pretty good. But there's one thing that they forget is that when the Flash runs really fast, the air in front of his face gets more friction and more friction and more friction. And they kind of saved it on the show by saying the suit is frictionless, meaning the air resistance doesn't cause friction, but his face is exposed. So if you actually put the Flash in real life, his face would catch on fire and he would burn up because of the air resistance. Okay, so that's one of the reasons the Flash isn't true. Plus, that wouldn't happen, but still. Mutations is Marvel's thing. Shh. The tendency for an object to change its motion, another way of saying it is objects be doing what they're already doing is due to what? Objects be doing what they're already doing is due to what? There's 20. Let's see. Inertia. Yes. Now, inertia is a Latin word. What is the English word for inertia? What's the English word? Lazy. And every object with mass has inertia. So every object with mass is lazy. You all have mass, so guess what you all are? Lazy. So the next time your parents come in and say, hey, stop being lazy, guess what you can say? I can't. It's the law. Which law? Newton's first law. Yeah. And then they ground you. But hey, it'll be a good story to tell your kids one day. Or maybe they'll be like, yeah, you learned something. Speaking of which, this question is like the last one. The greater the mass of an object, what is affected? And in fact, changing the mass of an object is the only way you can change this. By changing the mass of something, this is the only way you can change it. Verse 17, 18, 19, there we go. 20, let's see. The greater the inertia, yes, right? And it makes sense. The more mass an object has, the more it resists changing its motion. That's why heavy things are hard to move, because they are resisting you. That's why lighter things are easier to move, because they're not resisting you as much. But please remember, the only way you change an object's inertia, the only way is by changing its mass. Don't get tricked on a question like this. I have 2 cars. They're exactly the same, except one is parked and the other is traveling at 100 kilometers per hour. Which one has more inertia? They're both the same because they're both the same car. They have both the same mass. It takes just as much force to get that car moving as it does to get that car to stop. That's all inertia is, resisting its change in already moving motion. Any force that causes an object to go in a circle just like a tetherball, just like a planet. Any force that causes an object to move in a circle is called what? Question. How do you get things to move? Because think about it, you are also attached to the ground, so you actually take on the mass of the earth. That's how you can actually overcome that other force. Yeah. Yes. Yeah, good. All right, let's see. 27 answer that one. Centripetal force. Yes. Gravity, I would accept gravity, except I'm looking for the force causing it to move in a circle. Gravity is causing it to move in a circle, absolutely. But that circle force is called centripetal force. Okay? And then who put unbalanced force? You are one of the smartest ones in this room. Because it's true. The only way you can go in a circle is if you're constantly accelerating. And the only way you can constantly accelerate is if there's an unbalanced force acting upon it. So that is true. Now, if you did that for that reason, awesome. If not, like, yes. Christian, we'll say that you did it on purpose. Now, which of these examples is an example of a compression force? A compression force. Which is an example of a compression force? Ooh, that's a quick one. You guys got this. Let's see. Squeezing a sponge. Yes. Pulling a wagon is just a pulling force, right? It's all right. It happens. You get so excited. You just plucking a guitar string. Is that plucking a guitar string? What force is that? It is, but what's the more exact? Tension. Yes. Now, what if I ask this question? Squeezing a sponge is an example of this type of force, and I don't have compression force as an option. What other word would you look for? Elastic. Yeah. Remember, elastic is the generic term for anything of where the object wants to return back to its original shape, right? And there's two types of elastic: tension, right, which is a pulling force, and compression, which is a pressing or squeezing force. Okay, we're almost done. What effect does buoyancy have on a submerged object? I'll give you a hint. It's the same effect it has on an object that is not submerged. In fact, it's the same effect buoyancy has on all objects. The effect buoyancy has on an object. What does buoyancy want to do to objects? What does buoyancy want to do to objects? Let's see. Yes, it wants to move them up. Buoyancy is an upward force. What force is buoyancy trying to compete with? The force that's pulling you down. Gravity. But when we're talking about you and your mass and gravity, it's another word. It starts with a W. What is it trying to work against? Weight. Yeah. Right? Buoyancy is trying to work the opposite of weight. If an object floats, so let's think of like a boat, then the volume of water displaced is what compared to that boat? Think of the entire boat. The amount of water it displaces is what compared to the entire boat? The amount of water that's displaced in a boat that is floating is directly proportional to how much of that boat? If you don't know, talk about it with your group. All right, there we go. Let's see. Yes, it's only the portion that is submerged, not the entire boat. Now listen, remember when we were doing our density lab and we used the different ingots of metal, right? Just the different pieces of metal. They sank, and the volume that rose was the volume of the entire metal piece, because all of it went underwater. But if only a portion of the object goes underwater, that is the only amount that the water is going to rise. So displacement is only the amount of water that is submerged, object that's submerged. Okay. Now, if you push that entire boat underwater, the displacement would be even greater. And then you can get its buoyant force, and you will see that its buoyant force is greater than the weight of that water. That's how objects float. That's Archimedes' what? Principle. It would be the entire object if the entire object was underwater. But it's only the portion that is submerged is what the displacement is showing you. A ship will stay afloat as long as what? A ship will stay afloat as long as, oh, it's turned on. As long as what? Now, if you don't like ships, change it to something else. Anything. Blah, blah, blah will stay afloat as long as what? Here will stay afloat as long as what? There we go. We got 22. Let's see. As long as it is the buoyant force is equal to or greater than the ship's weight. Yes. As long as the buoyant force is equal to or greater than the ship's weight. Remember, staying afloat is a tug-of-war match in an up and down direction. If buoyancy wins, you float. If your weight wins, you sink. Okay? There's like 3 left. An object that is more dense than its fluid will what? Think about it. Water. What's water's density? 1. If there's an object that has a greater density than 1, what will it do? So any object that is more dense than the fluid it's placed in, because we've learned that not all fluids are the same density. So an object that is placed in something with a greater density will what? Sink. 100%. Awesome. Good. Very good. All right, next. This is the last one, and it's a math problem. A student, it could be you, finds an object, put it on a scale, and you see that it's 10 grams as its mass. You place it in water and see that it displaces 5 milliliters of water. So that's your volume. So if its mass is 10 grams and its volume is 5 milliliters, what is its density? What is its density? Let's see. Oh, before we see, what 2 answers can we cross off immediately? Immediately, Croakster. And why? Why can we cross those off immediately? Yeah, because those aren't densities. Yeah, they don't have the per, right? So you could cross them off instantly. So now we're down to a 50-50 shot. Or you can use your math. So what is it? 2 grams per milliliters. If you crossed it off first, you wouldn't have had that problem, right? So make sure you cross off what you know is wrong. Why would I put 0.5 grams per milliliter? What would I be doing there? Yeah, I want to see if you know the equation. If you flip it, you're going to think you got it right, but you got it wrong. So make sure you know the equation. Do you have to memorize the equation? No, right? You have your note page you can use with your equations, or I have this neat little black and white poster over here you can use with your eyes during the exam. The only thing that I'm not going to have on during the exam, which I'm going to turn off right now, is our LED scrolling sign. That's going to be turned off. I know. Okay, so that was our review. If you want to review it again tonight with your parents, you may do so. Check out your packet because that is due today. Yeah, you can turn your phones off.